So we've spoke about some high-level programming languages, but now let's talk about the rawest layer of computing. Let's talk machine code, the language your CPU actually understands. So high-level languages like Python or Java are for humans. Every time you run a program, your code eventually gets translated into a sequence of tiny instructions. Machine code, made of numbers in binary or more human-friendly hexadecimal. It's basically the computer's native accent. So what does machine code look like? Well, it's a string of opcodes and operands. Things like load this value into register A or jump to this address if the 0 flag is set. On a CPU, each opcode is a number. On screen, geeks usually write it in hex because binary is a wallet-sized nightmare, hence screaming hexadecimal at the sun. But how do we get machine code? Well, compilers and assemblers translate human-friendly code into assembly and assembly into machine code. Or if you're old school or a certain kind of mad scientist, you write it by hand. But why care? Well, there are a few reasons. Firstly, it's performance. Machine code is what's actually executed, so tiny changes matter when you need speed. Bootstrapping is the very first code that runs on a system, bootloaders and firmware, and it's often written with a direct eye on machine instructions. And then you've got security and hacking. Reverse engineering, malware and exploit development all happen at this layer. So if you want to understand how something really works or breaks, you better know the native tongue. But machines aren't poetic, they don't do abstractions. No garbage collection hugs you when you forget to free memory. That power is also a responsibility. So yeah, machine code is ugly, primal, and beautiful. It's the place where instructions stop being suggestions and become law. Drop a hex emoji if you want me to show an actual opcode breakdown at some point with the hashtag AskJack. But as always, keep questioning and exploring.